In a maze, when you have only one way to escape the endless roads and save the princess. Are you lost? Do you need help? Well, I will help you. Hi, I am Shan, and I share problem-solving techniques and how to think like a developer. In this series, I'm building many projects in C, making cool things while appreciating low-level thinking. Where every bit counts, let's get started. How can you create a maze? I first made a simple version to visualize the core idea of a maze. I used a 4x4 grid of integers where I could control which cells were passable and which were walls. Here is how I did it. I created a 2D array of integers. 1 means the cell is passable, 0 means the cell is blocked. I built a drawMaze function to print the maze using the gotoxy function, which places elements on the screen at specific coordinates. I tracked user movement with 4 arrows: up, down, right, and left. I used hashDefine to define the key ASCII values. Then I used a switch case to update the user row and user column. The player can move as long as they don't hit a wall, stay within bounds, reach the finished cell to win. Through this, I learned how to draw walls and pass, handle user input, detect winning conditions. But here is the challenge. How can you make the code think for you instead of hard coding every path? That's where the depth-first search algorithm comes in, and that's where the magic starts. In fact, I took it further by building levels, first a small maze, then it grows larger and harder, but always has one valid solution. What is DFS and how does it help? DFS, Depth First Search, is an algorithm used to traverse trees or graphs. In our case, the maze is like a graph. Each cell is a node, each possible move is an edge. So how does DFS generate the maze? Imagine you start with a solid block of walls, no path at all. Start at a cell coordinates 1 on 1 and mark it as visited. From that cell, shuffle the directions. We have 4 directions: up, down, left, and right. For each direction, move 2 cells away to make sure there is space for a wall in between. If the target cell is inside bounds and unvisited, then remove the wall between the current and the next cell. Recursively call generateMaze to make the next move. This is the DFS step. This continues until every cell is explored. As a result, you get a perfect maze with no loops. There is always a unique solution, and it's 100% generated through logic and code. Once the maze is ready, how do I show it? I built 2 display functions. First, drawMaze, which clears the screen, loops through the maze grid, sign for walls and the space for paths, green symbol for the exit, red symbol for the player. Second, draw player only function. I created this function because using the command line system CLS, which clears the screen, was too slow. It redraws the full screen every move. So instead, erase the player's previous position, draw the player's new position. Use gotoxy function to only update those cells. This keeps the movement smooth and efficient. And finally, the main function, the big boss. It handles game levels and the overall flow. For each level, sets a new maze size increase with level, allocates memory for the maze with initiate memory function, fills it with walls, which represents by 1, called generateMaze to carve path using DFS, sets the exit cell bottom right to 0 so it's reachable, then enters the game loop. Draw the maze once, constantly update the player with draw player only and user movement. If the player reaches the exit, they win. In short, you give the algorithm a starting point, and it generates a maze the way a human might explore a forest. One path at a time, marking visited places and never getting stuck in loops. So that's how I thought like a developer and solved the maze creation problem. What about you? Got ideas? Share them in the comments. Try it yourself and happy coding. See you in the next project.